Hi, welcome to QuBites, your bite-sized pieces of quantum computing. My name is Rene from Valorem Reply, and today we're going to talk about quantum computing and security considerations you should keep in mind. And I'm very honored to have a special guest here today, Lea Jäntgen. Hi, Lea. Welcome to the show. How are you today?
Hi, I'm good. Yeah,
awesome.
Thank you. I'm happy to be here.
Yeah, looking forward to a chat about quantum security. Can you tell us a little bit about yourself and your background as it relates to quantum computing and security?
Yeah, sure. So I'm working for Spike Reply, and we are responsible here in Germany for the security, IT security, basically all parts of it. At the same time, I'm part of the Reply COP, quantum computing. My background is in business informatics, but I really love all this quantum computing stuff. So I'm more self-taught there, but I'm really curious about the impact on security that quantum computing.
Awesome. So that is a really nice expertise here, like combining the business side of things, security, and quantum computing. So that's an amazing triangle. So let's dive right into the topics. And so what are the potential threats for quantum computing, in fact, for IT environments we're facing? Because I know, there are more qubits coming out in the next couple of years. And so, what are some of the potential threats actually that we might be facing?
So I think the most threat that we are facing is the uncertainty about how those things will go, and all the new algorithms that might occur. We already know that encryption is at risk. So the main threat is at the moment to encryption, because we know that there are already algorithms out there that can be a threat to encryption. But at the same time, we don't know which other algorithms might occur or might come up in the future when qubits become more and more advanced. So these are the main threats, and but for encryption we already know. And for encryption, there are two algorithms in quantum computing that can actually be a threat to them, and they're different for symmetric or asymmetric encryption. So if we talk about encryption, symmetric encryption basically shares a key, and if we want to crack this key, so there is the Grover's algorithm that can actually reduce the time to brute force the key by the square root. So we can much faster get to know the key. However, we can solve this pretty quickly by just enlarging the key and taking a longer key. For asymmetric encryption, it's more complicated, and there is also an algorithm called Shor's algorithm, which can, for example, do prime factorization in polynomial, what we call in IT polynomial time, which means I can basically crack RSA keys, for example, in a very fast time. And there's no real solution for that yet.
Right. So you can basically crack asymmetric keys like RSA really fast with quantum computing, and with the increased qubits we're going to see, that will be, well, in a few minutes or hours or days even, which would currently on classical hardware take 100,000 of years probably, right?
Yeah.
And so, yeah, I can totally see that this definitely is a big threat, because RSA is one of the most key pieces of the internet infrastructure as well, right? So it's like all over the place for all secure channels and so on, right? And so what are some of the alternatives that you could implement for current quantum computing weak cryptography algorithms?
Yeah. So one, as I mentioned, we could move away from asymmetric key encryption to symmetric key encryption, or to symmetric encryption, sorry. But symmetric encryption has some disadvantages, like key distribution. It's a shared key. I have to somehow transfer it to you if I want to use it, for example, to encrypt our communication. So there are disadvantages for symmetric encryption, but also NIST is working currently on a new standard to replace RSA with quantum secure asymmetric algorithms. And the last update there was on the 22nd of July. They announced that they are now in the final round, and there are 7 new finalists that actually they implemented, or that they developed more an alternative algorithms to RSA, for example, or quantum weak security. But NIST is not there yet. The standard is not there yet, but we are certain that in the next years it will come.
Yeah, I think there's also a lot of research at all the large tech companies and universities around these, how do you call it? I think post-quantum cryptography, or what's the name there?
Yeah, exactly. That's the name there. Post-quantum, post-quantum encryption also.
Yeah.
Yeah, so all these 7 finalists that NIST is considering in their standards, they come basically from this big tech companies or like universities, or there are a lot of submissions to this new standard.
And so while we wait for these new cryptography algorithm that are quantum computing safe, what can we do already now, and how can clients be prepared for the quantum computing supremacy, which we're going to see in our lifetime? And how does actually crypto agility help here?
Yeah, so as you already mentioned, we can become crypto agile. I think everybody knows what agility means in IT, kind of. So, and it's the same for encryption. We want to make our organization and our development and our IT systems the way that we can change our encryption algorithms very fast. So one example from reality, I was actually doing an encryption migration for a company where we had to manually replace 300 web server certificates, and took us months. Oh, so if we have an agile way with automation, with for example config files or something that we call crypto service gateways, where we have a single point where we can change our encryption algorithm, then we could potentially do this in minutes. We just roll out a new encryption algorithm. This is not only for the quantum age, but encryption algorithms break all the time. There are all the time new methods to break them. So this can help us now to not only prepare for quantum computing, but also for other threats. We also have to make sure that we include this in our organizational processes. So we have to include, if RSA becomes broken, we have to include it in our incident response plan. We have to know which algorithms am I using at the moment. So we have to evaluate an as-is state for our encryption. And last but not least, we have to use more DevSecOps, include security more in the daily development, and be aware of these things, and not say, oh, we have this one security department over there that's taking care of all of this. So that means crypto agility. Yeah.
Awesome. Makes a lot of sense. I just wanted to say that it all makes a lot of sense, basically. And in general, you should be agile, of course, and also especially with your infrastructure as it relates to security, right? Making sure that you can quickly change out these keys, because also and certificates and so on, right? Because I mean that should be done anyway, like you were saying. So. Well, awesome. Thank you so much for joining us today and sharing your knowledge about quantum security and the current threats and how clients can be prepared. Very much appreciate that you joined us today, Lea.
Yeah, cool. I was happy to be here.
Awesome. And thanks everyone for joining us for another episode of QuBites, your bite-sized pieces of quantum computing. Watch our blog, follow our social media channels to hear all about the next episodes and when they are coming out. Take care, stay safe, and see you soon. Bye-bye.